be going through this Ultimate Guide to React Native Optimization 2023 edition. This book is from CallStack. So these are the table of contents. So optimization of React Native is a complex process where you need to take various aspects into account, from implementation through using the latest React Native features to testing and continuous deployment. This guide is a comprehensive source of tactics, tricks, tips, tools and best practices to help you deliver an optimized React Native app. We not only focus on technological aspects of React Native optimization, we also underline the impact of each technological aspect on business continuity. This guide contains best practices for optimizing stability, performance, resource usage, user experience, maintenance cost, time to market, etc. All these aforementioned aspects have a particular impact on the revenue generating effectiveness of your app. Such elements as stability, performance, resource usage are directly related to improving the ROI of your product because of their positive impact on the user experience. With a faster time to market, you can stay ahead of your competitors, whereas an easier and quicker maintained process will help you reduce your speeding on that particular process. What this guide looks like and the topic it covers: this guide is divided into three parts. The first part is about improving performance through understanding the React Native implementation details and knowing how to maximize them. This part covers the following topics: pay attention to UI renders, use dedicated components for certain components, think twice before picking an external library, always remember to use library dedicated to the mobile platform, find the balance between native and JavaScript, animate at 60 fps no matter what, replace Lottie with Rive. Actually, I was a big fan of Lottie, and I think for Lottie iOS they have just released a new version of Lottie. I think it is version 4, where they have achieved significant performance improvements, but I think the Lottie library for React Native might not been updated. So yeah, this is pretty interesting. So Rive only started with Flutter when it was first launched, but it's good to see that Rive is replacing Lottie, at least in the at least for call stacks. Optimize your app's JavaScript bundle. The second part is about improving by using the latest React Native features or turning some of them on. This part describes the following topic: always run the latest React Native version to access the latest feature, how to debug faster and better with Flipper, avoid unused native dependency, optimize your Android application, start off with Hermes, optimize your Android application size with Gradle setting, experiment with the new architecture of React Native. The third part is about enhancing the stability of the application by investing in time and continuous deployment. This part tackles the following topics: run test for key pieces of your app, have a have a working continuous integration in place. Don't be afraid to ship fast with continuous deployment. Ship over the air in an emergency. So please be careful with OTA or over the air. Like we were using Microsoft App Center, and we tried using OTA. It used to work fine on iOS, but it was terrible on Android. Like I have tested this in 2021, and after that I stayed away from OTA. Also, the other problem with OTA is that even if you have installed a freshly new app and the developer has pushed an OTA like 5 minutes ago, and you clicked on the newly installed app, you will see a pop-up saying that there is a new update for your app, and this might be confusing for the user because they have just installed a fresh version of your app. Why there is an update again? So this is very jarring experience. Like I have only used App Center. I'm not sure if there is another service which supports OTA. Facebook might be using their own in-house infrastructure for OTA, that's for sure. Making your app consistently fast. Know how to profile iOS, know how to profile Android. The structure of each section looks like this. Issue: this part describes the main problem with React Native performance. This part outlines how the performance may affect your business and what the best practices are to solve it. This part focuses on the business benefits of your proposed solution. Introduction to React Native optimization. React Native takes care of the rendering, but performance is still key. With React Native, you create components that describe how your interface should look like during the runtime. React Native turns them into platform-specific native component rather than talking directly to the underlying APIs. You are focused on the user experience of your application. However, that doesn't mean all the application developed with React Native are equally fast and offer the same level of user experience. Even every declarative approach, including React Native, is built with imperative APIs, and you have to be careful when doing things imperatively. When you are building your application the imperative way, you carefully analyze every uh, call side to the external APIs. For example, when working in a multi-threaded environment, you safely write your code in a thread, being aware of the context and resources that the code is looking for. Despite all the differences between declarative and imperative way of doing things, they have a lot in common. Every declarative abstraction can be broken down into a number of imperative calls. For example, React Native uses the same APIs to render your application on iOS as native developers would use them. React Native unifies performance, but that doesn't makes it fast out of the box. While you don't have to worry about the performance of the underlying iOS and Android API calls, how you compose the components can make all the difference. All your components will offer the same level of performance and responsiveness, but is same a synonym for best? It's not. That's when our checklist comes into play. Use React Native to its full potential. As discussed before, React Native is a declarative framework and takes care of rendering the application for you. In other words, you don't dictate how the application will be rendered. Your job is to define the components and forget about the rest. However, that doesn't mean you should take the performance of your application for granted. In order to create fast and responsive application, you have to think the React Native way. You have to understand how the framework interacts with the underlying platform APIs. If you need help with performance, stability, user experience, or other complex issues, you can contact Callstack. As a React Native core contributors and leaders of the community, we will be happy to help. Improving performance by understanding the details of React Native implementation. In this section, we will dive deeper into the most popular performance bottleneck and the React Native implementation details that contribute to them. This will not only be a smooth introduction to some of the advanced React Native concepts, but it will also let you improve the stability and performance of your application by performing small tweaks and changes. The following part is focused on the first point from the checklist of performance optimization techniques. UI re-renders, it's very important part of the React Native optimization process because it allows for the reduction of device battery usage, which translates into a better user experience for your app. Pay attention to UI re-renders. Optimize the number of state operation and remember about memoized components to make your app work faster with fewer resources. Issue: incorrect state updates cause extraneous re-rendering cycles or device is just too slow. uh, as discussed, React Native takes care of the rendering the application for you. You have to define all the components you need and compose the final interface out of this smaller building blocks. In that approach, you don't control the application rendering cycle. In other words, when and how to repaint things on screen is purely React Native's responsibility. React looks out for the changes you have done to your components, compare them, and by design only perform the required and smallest number of actual updates. By default, the component can re-render if its parent is re-rendering or the props are different. This means that your component's re-rendered method can sometimes run even if their props didn't change. This is an acceptable trade-off in most scenarios, as comparing the two objects, the previous and the current props, would take longer. Negative impact on performance: UI flickers and FPS decrease. While the above heuristics are correct, most of the times performing too many operations can cause performance problems, especially on low end mobile device. As a result, you may observe your UI flickering when the updates are performed or frames dropping while there is an animation happening and an update is coming along. Performance premature optimization may have a counter positive effect. Try looking at performance issues as soon as you spot dropped frames or undesired performance with your app. As soon as you see any of these symptoms, uh, it is the right time to look a bit deeper into the application lifecycle and look for extraneous operation that you would not expect to happen. how do we know what to optimize when it comes to performance optimization? We want to make a decisions based on data. That data comes from measuring performance using specialized tools. The process is often referred to as profiling. There are many tools available that can help us with profiling our React Native apps. React Dev Tools, why did you render, Profiler, and others. For example, we will use Flipper, a platform for debugging iOS, Android, and React Native apps. It has React Dev Tools Profiler integrated as a plugin that can produce a flame graph of the React rendering pipelines. As a result of profiling, we can leverage this data to measure the re-rendering issues of your app. Once you have downloaded Flipper, select React Dev Tools. Okay, here's the code we are about to profile. Okay, they have taken a state. Okay, there is a background style, there is a use effect hook. The value gets updated after every 3000 second, 3 seconds. The value get updated after every 5 seconds. And there is this colored view component. Okay, and colored views look something like this. Okay, is a basic view. The Flipper app, make sure the record of how each component rendered while profiling option is enabled. In the settings icon and hit the round blue button to start profiling. After around 5 seconds, hit the round red button to stop profiling. Your profiling will look something like this. A profile shows how much time a certain component took to render, how many times it re-rendered, and what was the cause of it. In our case, the colored view rendered 2 times due to the parent component be re-rendered. This might give us a hint that there is an unexpected performance implication of the code associated with colored view. Using this knowledge, we can apply tailored solution to avoid extra re-renders. Take a look at the performance flavor graph for the first time. May be slightly intimidating to understand React DevTools more in depth. This video from Ben Award is good at explaining it. Don't forget to watch this talk by Alex at React Native EU, which explains us how we can use Flame Graph to identify and fix the issue. Also, visit our official React website for more detailed information on React Profiler solution. Optimize the number and remember to use Memoize component. There are a lot of it. Your application can turn into unnecessary re-rendering cycles, and that point itself is worth a separate article. Here we will focus on two common scenarios using a control component such as text input and a global state. Control versus uncontrolled component. Let's start with the first one. Almost every React Native contains at least one text input that is controlled by the component state as per the following snippet. Okay, there is a useless text input. Okay, useless text input. The above code sample will work in most cases. However, on slow device and situation where user is typing, it may cause problem with it. The problem is caused by React Native's asynchronous nature. To better understand what's going on here, let's first take a look at the order of standard operations that occur when the user is typing and populating your text input with new characters. As soon as the user starts inputting a new character into the native component, an update is sent to React Native via the onChange text props. React processes that information and updates its state accordingly by using state next. A control component synchronizes its JavaScript value with the native component. There are benefits to such operation. approach. React is a source of truth that dictates the value of your input. This technique lets you alter the user input as it happens, by example, performing a validation, masking it, or completely modifying it. Unfortunately, the aforementioned approach, while ultimately cleaner and more compliant with the way React works, has one downside and is most noticeable when there are limited resources available and or the user is typing at a very high rate. When the updates via on-change text arrives before React Native synchronizes each of them back, the interface will start flickering. The first update operation and operation 2 performs without issues. As the user types the next, operation 3 arrives, is followed by operation 4. The user types E and S while React Native was busy doing something else, delaying the synchronization of letter E. As a result, the native input will temporarily change its value back from TES to TE. No, now the user was typing fast enough to actually enter another character when the value of the text input was set to TE for a second. As a result, another update arrived with the value of TET. This wasn't intentional. The user wasn't expecting the value of its input to change from TES to TE. Finally, operation 7 synchronized the input back to the correct input received from the user a few characters before. Operation 4 informed us about TES. Unfortunately, it was quickly written by another update, operation 8, which synchronized the value to TET, the final value of input. The root cause of this situation lies in the order of operation. If operation 5 was executed before operation 4, things would have been run smoothly. Also, if the user didn't type T when the value was TE instead of TES, the interface would flicker but the input value would remain correct. One solution for synchronize is to remove the value prop from the text input directly. As a result, the data will flow only one way from native, so eliminating the synchronization issues that were described earlier. So I think they are using the default value instead of value prop. Here they were using value. Okay. However, as pointed by N. Parshuram in his YouTube video, which is a great resource to learn more about React Native performance, that workaround alone isn't enough in some cases. For example, when performing an input validation or masking, you still need to control the data that the user is typing and alter what ends up being displayed with text input. So yeah, that's it for today's video. We will continue on with the next one. Thank you for watching. Bye.